All right, team. I'm going to try and do this relatively quickly because it's starting, well, it'll be dark soon and I need to bike home. And I don't have lights on my bike today, so let's get cracking. Set number 4, answers for problem solving. Okay, the one that looks like this, just for your reference. All right, question number 1 says, Kyra made up bags of sweets for the school fair. In each bag, she put 4 caramels and 7 jelly babies. She packed 36 caramels. How many jelly babies did she pack? So let's have a look at this. 36 caramels. Each bag she put 4 caramels. So that must mean 9 bags. Okay, because number 1, 36 divided by 4 equals 9. Okay, and because of that, 7 jelly babies, so we just have to go 9 times 7, and that should give us our answer. Okay, so the first one there should equal, I'll just double check with what I have put down, 63. Okay, nice and easy to start us off. Alright, number 2. Says, give the next number in this sequence. We have 3, 5, 8, 12, and 17, etc. Okay, this is our sequence. Now, quite often with sequences like this, the thing that I like to do is to look at the difference between the numbers. So as we can see there, the difference between 3 and 5 is 2. The difference between 5 and 8 is 3. The difference between 8 and 12 is 4. Between 12 and 17 is 5. So you can see that the difference is increasing by 1 each time. So that makes it pretty easy. The next difference would be 6. So 17 plus an extra 6 will give us our final answer of 23. Quite liked those first 2 problems. Nice and easy way for us to start. Okay, question number 3. Jim's granddad is 57 and his mother is 23. In how many years will Jim's granddad be twice as old as his mother? Okay, so there's a couple of ways you can do this. You can use the guess and check method, which is the tried and true method for lots of you. But as I always say, that sometimes is a little bit longer. So the faster method, is to go 57 take away 23. So that's looking at the difference between the 2 ages. So 57 take away 23 is 34. That's the first part of the problem. 57 take away 23 is 34. Okay, so that would mean, because based on that difference, that when Jim is 34, then his granddad should theoretically be 68, which would work. So what I need to determine is how many years will it be until Jim is 34. So he's currently 23, so we just have to go 34, take away 23, and that equals 11. Okay, and checking that off in 11 years, if he's 23 now, 23 plus 11 is 34. Jim is 57, so if we add on the 11 there, 57 plus 11 is 68. So let's just double checking our answer to make sure it's correct. And it is. The answer is 11 years. Okay, moving through nice and quickly, which is excellent for my bike ride. Number 4. This one I found a little bit confusing, to be honest, but I'm interested to hear how you guys got on with it. I got one answer, but then when I checked the final answers, mine was slightly different to what the book says. So I'd love to know your thinking around this one. It says, the bus journey between Aspen and Bedley takes exactly 1 hour in either direction. Buses leave Aspen every 10 minutes, starting on the hour, for example, at 9 o'clock, 10 past 9, 20 past 9, etc. Buses leave Bedley every 10 minutes, starting at 5 minutes past the hour, for example, at 9:05, 9:15, and 9:25. If you travel by bus from Aspen to Bedley, how many buses coming the other way would you see? So what I started to do is I just imagined, it doesn't really matter what time you use here, but I imagine leaving at 9 o'clock. Okay, so if I was leaving at 9 o'clock, and leaving at 9 o'clock, it means I would arrive at 10 o'clock because the journey takes 1 hour. Okay, From the other side, so when I did this, I imagined that there was a station here and a station here. So I imagine there were buses at each station each morning, which is probably where my confusion is compared to the other answer. They would leave the other station, so this station here, if I was here leaving at 9, the buses from this station here have to leave at 5 past to get back to here, if that makes sense. So that means that as I was on my 9 o'clock journey, I should see the buses that leave at 9:05, because remember, their final one will arrive at 10:05, okay? So I'll only cross over, I'll only see buses that cross over the journey at certain parts. So 9:05, I'll see the 9:15, I will see the 9:25, and I'm just going up in multiples of 10. I'll see the 9:35, I'll see the 9:45, and I'll see the 9:55. Okay, those are the buses. Because I'm arriving at 10 o'clock, the bus that leaves there at 10:05, I won't see. So there are 1, 2, 3, 4, 5, 6. Now that's what I put as my final answer, because the question asks how many buses coming the other way would you see. But when I checked the answers, it said actually you would see all of these. So I was correct in saying this. It says you would see all of these, but it said you would also see the buses that are going from the station to the opposite end in order to come back. Okay, so they've said that you would actually see another 6 more, which would be the ones getting from Aspen to Bedley. Now that's, I guess, presuming that there's only one bus station where the buses actually stay overnight. Okay, so the final answer, according to the book, is 12, but I will accept 6 if you've used the same working method as me. But officially, according to the book, the answer is 12. Final answer. Okay, and question number 5. All right. This one just requires a little bit of drawing, so I'll set this up. So a bit of long multiplication. Let's see, lots of 8s in this one. 1, 2, 3, 8. Oh, actually, sorry for the delay, but I've run out of space on my thing, so I'll start that one again. Something, 8, something. Okay, now it's just this big long multiplication problem, and we have to go through this in steps. Okay, so that's what it looks like. It says here, in this long multiplication, all of the 8's digits are shown, but all of the other digits shown as blank are missing. When the multiplication is completed correctly, what will the final answer be? Okay, now the first thing that we do know, okay, is that these two here, so in the second line here that we're trying to work out, we know that 8 times 8, that's one thing that we have no blanks to fill in. So 8 times 8, as you will probably know, or you'll work out by the time I finish this explanation, 8 times 8 equals 64. Okay, so that's for this line here, so that's, we're looking at this digit here, so 8 times 8, 64. So we need to put down the 4. We know that for certain. And then what I'm going to do is we know that we would carry the 6. So I'm just going to keep that one up there, just for the moment. Okay. Now remember, this is for the second line of the problem because that's where the 8th digit is there. Okay, knowing that, we can work out that this one here, because if we add this bottom bit, something plus 4 equals 8, we know that here equals 4. They were the first 2 numbers that I was completely sure of, okay, which gives us a few clues into what the other ones, are. All right, what do I next work out? Okay, looking at this one here, okay, so something times 8, looking at this one, hopefully you can see that, so blank times 8. Now the thing here, it has to equal 8, and because it's only a 3-digit number, we know that this one here, this calculation cannot be a 2-digit number. Okay, it cannot be more than 1 digit, because otherwise there'd be an extra one here. So I know that something times 8 equals 8 must be 1. All right, so I know that for certain that one there equals 1. Okay, hopefully that makes sense. Now the next one that I worked out was that top line there equals 0. Now how did I know that? There is some reason why I knew that had to equal 0. Let me just calculate this myself. I knew it had to be. I'm just going to write it in. I know that this is 0. I'm just going to try and explain myself. I've got lots of numbers and stuff written down in front of me, and I can't. It's quite tricky actually to explain your thinking. But I know that this is 0. The reason why I know it is a 0 is because I think it's because it couldn't be a 2-digit number. Let me just get this right. I'm just going to pause the video there, guys. All right, I've worked it out. I've worked out what I was trying to say before. The reason why I know this had to be a 0 is because of this 6 up here, okay? Because I know if I carry the 6, if it was anything bigger than a 0, for example, if it was a 1, that would mean that by carrying that 6, okay, it would make it a number that would affect this number here, and that would no longer become an 8. Okay, that would, because I'd have to add on extra numbers. Okay, so that's the reason why I know that there is a 0. Okay, moving on. Actually, now that I know this, we can work out something else. So we can work out all of these numbers here. So 8 times 8 is 64. So I'll put down the 4 and I'll carry the 6. 0 times 8, we know 0 plus the 6 equals 6. 6 plus 0 equals 6. So that would be 864 there. So this is what we know so far. All right, we've got those and we know that they are 100% correct. Okay, for the next part, because we have got the 4 here, okay, because we know that 4 and 4 equal 8, because we've got the 4 here and we know that it's 0 times something to get us this number here, we know that we must have carried a 4 somewhere. Okay, so somewhere along the line we must have carried a 4. Okay, so that gives us a bit of a clue. That tells us that this part of the number here must be something in the 40s. Okay, it must be 40 something. So trying to work out 8 times something which would equal 40 something, we've got two options. We've got 8 times 5 equals 40, and we've got 8 times 6 equals 48. We know that it can't be 48 because all of the 8s are already loaded into the problem. So that must mean that this one here is a 5 to make it 8 times 5 equals 40. So 8 times 5 equals 40, which is where we get the carry of the 4, okay, which gives us this one here, because 0 times 5 is 0 plus 4, okay, equals 4. All right, and that just leaves us with one last bit, which is the 1 times the 5, which leaves us with a 5 in there. Okay, now that we've got those figures, it means that we can easily do the rest. It's just a simple bit of adding. Okay, so we know that the 0 going down here just stays as 0. 4 and 4 equals 8. 5 and 6 we know equals 11, so we put down the 1, carry the extra 1, and that would equal 9. So our final answer for that one there, because it says when the multiplication is completed correctly, what will be the final answer? It will be 9,180. And that's the answers for all of the problem solving questions this week. Well done if you managed to get all of those correct, or if you managed to get a few of those correct, or even if you just gave them an attempt. You might have got them all wrong, but you never know. You might have learnt some stuff from watching the answers. And like always, if you have any questions, please post on your maths problem solving channel in your class teams, and then I'll be able to help you out with anything that you need clarification over. All right, team, I hope you have a wonderful weekend, and I will see you guys again next week. Remember, Team Taniwha, we are trialing a Zoom meeting at 9 o'clock on Monday morning. So if you're watching this between now and then, make sure you tune in at 9 o'clock on Zoom. The link will be in your class team, and we will see you then. All right, guys, ka kite anō.